Hi, SHARE UAV has sent me a SHARE S20, the LiDAR scanner for review. The case looks different from the SHARE C1. It's bigger. If you order the SHARE C1 from the Kickstarter campaign, the package will be different. It will come in a sling bag. When I use the C1, I think I don't need a second battery because it's fast charging. It's the same battery as the C1 with a grippy rubber, just different in the color. This will be the LiDAR. It's the same Livebox 360. The chassis is made from die-cast aluminum, same as the SHARE C1, and the photo cameras is different. It's quite big. This one is 16 megapixels, and for the SHARE C1 is 2.3. So this is a 4K photo cameras. And if you look closely under the letter A, you will see a small video camera. This will be the visual SLAM sensor for tracking the repeat pattern, and also it comes with the RTK antenna. It's built in, so you cannot remove it. Okay, it's the same mechanism that I use with the C1, and yeah, it comes with a base plate so that you can use it for collecting the control point, a U-green PD charger, 65 watts GAN charger. Inside the box, SD card reader, which is also from U-green. One side USB-A and one side USB-C. A phone holder from DJI, same as the C1. And the rest would be like a cleaning cloth and a manual. Okay, this will be the construction site, a 3-story house that I always use to test the LiDAR scanner. The corridor and stairs are very narrow, about 90 centimeters, and this can cause the LiDAR scanner to lose tracking when it is scanned in just one pass. The S20 preview screen is as responsive as the C1, and I use that a lot to check the blind spot. This scanner is the same as the C1. The Livebox sensor is aligned at 25 degrees to the horizontal plane, so I have to sit down regularly to capture the blind spot on the floor, which is about 2.8 meters in front of me. So when you have to scan a small interior space like this, you should have a very good knee. I still have a pain on my legs after I made this scan. Now I'm reaching the 3rd floor, and this will be the second LiDAR scanner that can come up this far without any drifting. The floors are still parallel when I look in the preview screen. The first LiDAR scanner that can do this is the SHARE C1. Okay, here's a warning. It's very dangerous to walk backward in the construction site. You should not work alone, and you should have a spotter to check for the safety. 14 minutes of the scanning time, 200 meters of the travel distance. The start and the end point is matching exactly. The IMU sensor works very well. There is no noticeable error on the preview screen. Okay, there are several ways that you can transfer the scan data from the scanner to your computer. The easiest way is by removing the micro SD card and use the included SD card reader. This is the fastest way. can read up to 100 megabytes per second. The S20 use the SanDisk Extreme. It says right here a V30. The second way is by connecting it to the USB-C cable, and you need to use the high-speed data cable. It's not included in the package. The include charging cable will not work, and you can plug another end to your USB 3.0 port on your computer. You need to connect the phone to the scanner. Click on here, USB mode. This will activate the USB mode on the scanner. The transferring speed is lower than SD card reader. It's about 50-60 megabytes per second. Okay, here's in the Share Point Cloud Studio. I'm going to process the point cloud S20. Click on the folder. It's going to detect the folder. And now you have options. RTK Fusion is off. I will scan indoor control point calibration. I'm going to demonstrate in the next scan. Dynamic object filtering. This will remove the moving objects. Distortion, remove photo output. This will generate a flat photos that you can use it for making 3D Gaussian splatting. So I'm not going to turn this on yet. Next, I'm going to click on start the calculation. Okay, this will be the scan data from S20. I can't even see the seam line on the ceiling. The gypsum board is 1.2 meters. So I'm going to measure 1.203. Yeah, 2.4. This is the length of the gypsum board. So the accuracy of the color point cloud is very, very good. The point cloud color is 56 million points. I still have a blind spot here, even though I sit down in the corners. Okay, so if I sit down before I enter the stairs, you see that the rise of the stairs are captured. Okay, this room has a blind spot here. I don't see any different from the C1 in terms of the quality of the scan. Let's go to the ground floors. That's my scooter. Okay, this is in the cloud compare. Okay, now the first floor is aligned. Second floor aligned. Third floor is aligned. Okay, next I'm going to slice for the... Okay, this will be the third floor. Let's check the parallels of the wall. Yeah, the corner of the wall is round, same as the C1. Yeah, parallels. And the wall gives a right angle. So it gives a good precision with the SLAM algorithm, same as the C1. Okay, let's move to the second floor. Yeah, parallels. No issue with the wall, not parallel. 90 degrees angle. Let's go to the first floor. Don't expect any error on the first floor. First floor is quite easy. It's precise enough for making the reverse engineering. It is a bit round, but you can reverse this. Yeah, the cross section of the building is quite clear. Yeah, third floor is parallel. Second floor parallels. Some corner is round. Yeah, I told you before it's round. Precision is good. Accuracy is good. There's nothing outstanding over the C1. Pretty much the same result. for interior scanning. But if you look at the image quality, the image is 4K, 3500 by 4600, so it's vertical image. Unlike the C1, C1 is horizontal image. Now I'm placing 4 markers on the floor in a rectangle shape, 1.2 meters, and one side is parallel to the wall in this room. So I will have 4 known coordinate points that I can use for referencing the scan data. And the click sound that you are going to hear is from the camera shutter. Okay, now I'm placing the scanner on the board and click on the control point function. It's going to take about 10 seconds to collect 1 point, and you will need at least 4 points to make a control point calibration. Okay, now I'm going to click on control point calibration. It will ask you to input the coordinates of the 4 control points that I collected. So I'm going to put point 1 is 0, 0, and 0. Point 2, x is 0, y is 1.2, and z is 0. X is 1.2, y is 1.2, and z is 0.4. X is 1.2, y is 0, and z is 0. So there will be 4 points. Okay, this will be the scan result from using the control point to align one side of the wall to the y-axis. So let me check. Yeah, it aligns perfectly without manual alignment. You can use this for aligning multiple scans together. For example, you need to scan a very large area. So you want to split the scan into 2 loops. You want to align them automatically. So you need to use the control point, placing 4 boards or 4 marking on the floors with the known coordinates. So it's the easiest way is to make it in a rectangle using a measuring tape and check for the diagonal. So you can use this for inputting the coordinates like 3 meters. This one will be so the A and B will be positioned in the same spot here, and you can align them without doing the manual alignment in Cloud Compare. So this is a most used scenario for the control point. Slice point cloud. This 2 checkerboard is parallel to this wall. So this wall is super parallel to the y-axis. Yeah, 1.203. So if you are using the SHARE C1, which is it doesn't come with the control point collection function, you can use the workaround by using the checkerboard, placing it on the floor and use your mouse to click it, and you can integrate the geo-referenced or align the point cloud to the known coordinates. Using this function, it will align your data. You need to use the mouse for clicking. It's A0, and the second reference, you're going to type in the coordinate. Control point will give you a higher precision than picking the point by using your mouse. Okay, if I click on here, I need to look at the XG, YG, and CG. It's going to display 0, 0, 0. When you click on the normal icon, it's going to show you the health status of the hardware. You can check the status of the LiDAR, the main camera, main board, and also the batteries. Now I'm turning on the RTK function. SHARE S20 will correct the GPS coordinate in real time. So you need to have an N-Trip account from your provider. In the mobile app, you need to provide the ID, password, server IP address, port, and the mount point. and you need to get this information from your Ntrip service provider. Without Ntrip account, your RTK will not work, and in some location this service is not free. One special thing about S20 RTK is that I get a fixed solution very fast, even faster than my survey grade RTK that I'm using. Usually I need to wait like a few minutes to get a fixed solution. When you scan with the RTK fixed solution, you do not need to come back to close the loop. So when you fuse the point cloud in SHARE Studio, the software will use the GPS coordinate for calculating the trajectories. So the accuracy of your scan will only rely on the accuracy from the RTK. Now I'm receiving 50 satellites. With this number, I should get plus or minus 8 mm in the horizontal and plus or minus 15 mm in the vertical. So plus or minus 8 mm that can create a wall thickness of about 16 mm, right? So the point cloud wall thickness that was scanned from the RTK will be thicker than the point cloud that is generated by using the SLAM algorithm. But in some scenario where you cannot do the loop back to the starting point, or you have to scan in the open area like in this field with no feature, the RTK will give you the highest accuracy. One other benefit for using the RTK is that the point cloud will have the GPS coordinate. And when you import this point cloud into CAD software, you can extract the GPS coordinate and use it for staking out, for example, locating the position of the foundation. Okay, next I'm going to walk between these two buildings, and many of the RTK will lost the connection, but this one is working. I still get the fixed solution, so I'm going to try again. Now you can look at the RTK status. Now it's fixed, fixed, float, fixed. So it still get fixed solution most of the time in a narrow space. The GPS antenna on this device is very good. Now I'm going to stop the scan without returning to the starting point. So it's 400 meters in 8 minutes. So you can scan a larger area in the same amount of time because you don't have to walk back to close the loop. Turn this on. I'm going to choose the known coordinate system. My Ntrip provider, we use WGS84 and the zone is 47N. Okay, trajectory files, I choose built-in RTK trajectories. So when I turn this on, it will neglect the SLAM algorithm. It will purely use the coordinates from the RTK for positioning the scanner. The quality of the scan is rely on the precision of the RTK and your Ntrip provider. Okay, this will be the scan result using the RTK on S20. The scan point cloud, it will align itself to the true north. Y-axis is the north, and on the right of the x-axis will be the east. So you have a orientation of the map automatically. And if you click on the point, it's going to show you the global coordinates. Click on save, and then you can click on copy. And you can go into this website, click on the collect zone WGS84 zone 47 end, and next I'm going to paste the coordinate. This will be the X and this will be the Y. Click on go to, and if I zoom in the Google map, it's going to show you, so this is the same point as shown in the Google map. This will be the first route I'm walk here. The color looks good. I think the slam color point cloud looks better with higher detail. Let's get into the yard. Yeah, the yard look good. This kind of scenario, you need to use the RTK open area with no feature. So RTK is going to work well. Okay, this is in the AutoCAD. This is the most use case that I do with the SLAM LiDAR RTK. So you can get the position of the foundation for staking out using the GPS. Should reach somewhere around 1, 2, 3, 4, 5, 6. Yeah, 30.003. So it's same accuracy as the SHARE C1. When I review it, I also used to measure this point 30 meters. It's only 3 millimeters earlier. Okay, on the right is the S20 with the SLAM. On the left is S20 with the RTK. With the RTK, it's going to give you a poor performance with the color point cloud. If you do the loop back, you should not return to the starting point when you are using the RTK. So it's going to give you this poor quality of the color point cloud because the first scan and the last scan is not matching. Okay, this is a good comparison. It looks very similar. Because I didn't do a repeat scan, I walked past this sidewall only one time. The RTK and the SLAM give a very similar result. So if you are using the RTK, do not go back to the starting point. It's going to deteriorate the color point cloud. Okay, next the S20 SLAM and the C1 SLAM. The result is very close. The difference I can see is the wheel. S20 give a clear image of the wheel than the C1, and for the car body it's the same. I think it's the same. Yeah, there's no difference. A little bit better for the S20 on the lower part of the car. Okay, this will be the final comparison. This handrail is look mushy on the C1, clear with the S20, and also the grills here. S20 is clearer than the C1. And most important, if you look at the bushes, the S20 it can capture a darker area better than the C1. See the bushes, the C1 is appear to be lost in the detail, while the S20 is captured better. This is the point cloud, not the 3DGS. The result from the 3DGS could be different even more. But one thing you should notice that the S20 give like artifacts of the color on the flat wall much more than the C1. There's no artifacts, no color artifacts with the C1. Okay, I think that the artifacts from the wall is from the lens flare. There's a the lens is turning against the direct sunlight. I think it can cause the flare. Software map this color onto the wall. Yeah, there's a lens flare. I can see that. Yeah, I noticed this a flare of the lens on the ground as well. I think the S20 it has a larger glass element and it causes the lens flare. So you should avoid using it against the direct sunlight. The C1 it has smaller lens, so it has less effect on that. Sometimes I found this on the ground. The small tint red color, that's the lens flare. Okay, so what is the difference between these two scanner? The S20 priced at 4,999 and the C1 is 2,200 on the Kickstarter, but I don't know how much they will price it after this. The color point cloud quality is very similar. They both give a very thin wall cross-section of the point cloud and the same accuracy earlier. But in the darker area, the S20 will capture more detail because it has a larger camera sensors than the C1. But the S20 has more issue with the lens flare when shooting against the direct sunlight. And the S20 has the RTK, which works very well. The antenna on the S20 can capture the GPS signal same level as the survey grade RTK. And I can get a fixed solution very quickly and it stay connected all the time. So you can have a geo-reference of your scan data and you can also make a 3D scan without going to the starting point. There is no need to do the loop back. That will save a lot of time, and in many scenarios you cannot actually walk back to the starting point to finish the scan. The S20 also has this control point function. It can be helpful when you need to align the multiple scans together, while the C1 does not come with this function. The S20 has a high precision IMU sensors, while the C1 uses the include IMU sensor that come with the Livebox 360. Precision IMU sensor is for using in combination with the RTK when it lost the connection. It still can track using the IMU sensors for a moment, not too long. I think less than 1 or 2 minutes is fine for this IMU sensor. But the C1 here it doesn't need that high precision IMU sensor because it doesn't come with the RTK, so that won't be necessary. So in conclusion, you're going to need the S20 only when you need the RTK and the higher quality of the camera for doing the 3D-GS. Other than that, I think for general survey work, interior scanning, outdoor scanning, that you still can see the building in the 40 meters range. The C1 has no issue in tracking. It's going to perform as good as the S20. But if you are an architect, construction engineer, or surveyor, you don't even need to ask which model because you're gonna need this RTK functionality. The reliability of the RTK function on the S20 is very good. I tried more than 5-6 times yesterday and today, and it never fails. It connects every time I turn it on. That also depends on your entry provider. Okay, so here's my first review of the S20 and comparison with the C1. Thank you guys for watching. I see you in the next video.